In our most recent security awareness training, we looked at an application vulnerable to SQL injection. I browsed this web application, trying to use all the functionalities. In the case shown here, a poorly designed comment feature that allows for user input. While browsing, I used a web application attack proxy called OWASP Set Attack Proxy, or OWASP ZAP for short. ZAP recorded all my browser activity, including GET, POST methods, and HTTP headers and cookie data. This allowed me to launch an active scan attack against the application using one of ZAP's many features. The active scan attack sends all sorts of attack data at the application, including mangled SQL injection data. In this case, the attack data returned from the application revealed it was likely vulnerable to SQL injection. ZAP provides some information about alleged attacks in the sidebar where you can read about potential issues. The items marked in red are especially important to resolve, like SQL injection, and here's why. If I take the cookie data used in this browsing session and put it in an exploit application, like the following SQL map tool, it will not only detect the application vulnerability, but it can exploit the weakness as well. As we can see here, the data we found while browsing the site is displayed during the attack. The tools take some expertise to run. However, once you get the hang of it, you will find data popping up everywhere. In this case, we see the correlations table from the internal MySQL information schema database, followed by the character sets table. However, most importantly, the application extracted all of our user-stored PII data in clear text. We then reviewed an application that contained numerous application vulnerabilities, including the notorious 1=1 Boolean SQL logic bomb. This SQL injection weakness allows a user with malintent to log in without needing a password. In this case, we are logged in as Joe Vieja. This application was created by Foundstone, a software security training company. The supplied Hack Me Bank PDF details what you can learn from this weakly designed application. This training material allows you to go through the lessons one at a time as you read the PDF. It talks about web application attack proxies like ZAP and Peros, goes on to detail the 1=1 Boolean SQL logic bomb or login bypass exploit. It shows you that if your application is not failing safely, problems can result. For instance, in this case, instead of failing safely, the application returns database errors. These database errors can be used to construct a certain logic for attacking the application. Essentially, we are giving the attacker clues about our application which help them debug its weaknesses. It can even allow them to perform database table manipulation. The training material also covers horizontal privilege escalation using parameter manipulation. This allows an attacker to perform actions on behalf of other users. Similarly, vertical privilege escalation can be used to provide administrative privileges. In the case of an online banking application, this means allowing an unknown to transfer funds between different accounts, or essentially become part owner of the bank. The document also details cross-site scripting, which can allow an attacker to perform account takeover. This is a very good example of thorough training material, and we made this available through the Security Assurance webpage on a local file share. In future training sessions, we will be referring to this material given it covers more than just SQL injection attacks, and starts to talk about attack vectors using both horizontal and vertical privilege escalation scenarios. These are common security concerns among both business owners and application developers. Engineering tools, plus many pages of SQL injection issues, attacks, demos, techniques, methods to fix SQL injection, and resources available to learn more. When talking about prevention, I gave a very practical example concerning how SQL injection was preventable in my own code. I showed a particular code change and discussed why I was making the change. We then looked at the related methods and how simple the change could be, just commenting out one function and adding another entry point. Then we looked at the methods and explained that weak SQL code simply appends strings together to create an SQL expression from user inputs provided to the application, and then executes the user-supplied expression addendum. Hardened code, on the other hand, uses only prepared statements, or called procedures, only modifying the SQL syntax using prepared statement SQL parameter modification methods. This ensures the meaning behind the SQL expressions cannot be changed. I then saved the changes to disk, restarted Tomcat, and attempted to run the SQL map attack once again. This time the attack took sufficient time to execute. Going through various guessing attempts and enumerating and detecting if an SQL injection was possible for a variety of different database types. In the end, we found the injection was no longer possible.